Welcome to the lecture on data acquisition, part of the Principles of Data Visualization lecture series. Now, data acquisition has a number of different components. So we'll talk about defining data. How do we define data? What is it? What is data really? What are information and insights? What's the difference between data and information and an insight? What are data resources? Where can I find different data sets? Where do I start? And then we'll also discuss a data acquisition process. So what is data? Is it something a computer system creates? A bunch of bits and bytes? How about stuff in a database table? Who would answer and say, hey, I know what data is. It's a bunch of stuff in a database table. Or how about pulses of light? So we have fiber optics, maybe it's pulses of light. Or how about this answer, always very popular, it's something Google makes. So data is an observation. So what we see represented here, basically a phenomenon. So I've represented for you guys, we've got a nice Bunsen burner here, sitting on top of a stand. We have a beaker of liquid, perhaps water, and we're observing what's going on here. Now, our observations, our recording of measurements is the creation of data. Okay, so we're illustrating for you here the data as it's created. So at different intervals, we might measure the water temperature. It's 113 degrees Fahrenheit at 5:28 p.m. 3 minutes later, it's 127 degrees Fahrenheit at 5:31 p.m. A few minutes later, it's 149 degrees Fahrenheit at 5:44 p.m. And then it's 177 degrees Fahrenheit at 5:50 p.m. So this is data. We are basically capturing measurements, and those measurements are data. Now, there's several different types of data. We have what's known as nominal data. So with nominal data, we assign measurements to a category. So, categories might be as simple as the blue team, the red team. Might be several different labels or tags that we assign that would be known as nominal data. We also have ordinal data. So with ordinal data, measurements are organized in an order or a sequence, just like it sounds, ordinal order. So they are organized in a sequence. Then we have interval data. So with interval data, measurements are in equal positions from each other. And we'll go over an example of each of these. With ratio data, which we utilize ratio data for our quantitative measures quite a bit. These are measurements that can be used as fractions or multiples. And what I've done in representing the types of data for you, I've given you what I think is the most extensive list of data types, as well as what I think is the most popular and most helpful for you to understand different types of data. And you'll see in some of the different texts, you'll see some representation sometimes that say there are 3 types of data or there are 4 types of data. But what we've done is given you the most definition here. So nominal data. So nominal data is composed of categories. So our product categories, we might represent data as different product categories. For example, smartphones or laptops or servers. So these are good examples of nominal data, different categories. Ordinal data. So as we described, ordinal data is defined by a sequence. So we might have a list of our top 10 customers. So Exxon, AT&T, General Motors, KB Homes, Kimberly-Clark, etc. So we have a list of the top 10. Now, one of the things I want to note is each of these different pieces of data may not be equivalent distance from each other. So Exxon might be $100 billion in revenue. AT&T might be $98 billion. General Motors might be $89 billion. KB Homes might be $70 billion. Kimberly-Clark might be $50 billion. And so we might have a sequence of our top 10 customers, but their revenue amounts may not be equally divided. Then we get to interval data. So with interval data, data is defined by an equal distance between the units. So only relative values are significant. Basically, there's no absolute or 0 point. So what we see here with interval data is that we have intervals. So 97 degrees, 98 degrees, 99 degrees, 100 degrees, 101 degrees. So what we see here is a 1 degree difference between each of these that is that equal distance between units. And then finally, we have ratio data. So ratio data is defined by numeric ratios of comparisons. So these use an absolute 0 point. So a couple of examples here. $25,000, and this is as compared to 0. Now typically we wouldn't say it that way. It sounds kind of weird. Our typical speech pattern is that we just drop the compared to 0. But in fact, the 25,000 is meaningful in that it is a comparison to 0. So $25,000 compared to 0. We might also have 10%. So 10 compared to 100. So that's 10%. Or we might have 400 hours, again, compared to 0. So it sounds sort of strange to say it that way. 400 hours compared to 0. Typically, we just say 400 hours, but the meaning of that statement is 400 hours compared to 0. So we're utilizing, with ratio data, we're utilizing that absolute 0 point. So we also have continuous versus discrete data. So continuous data elements can take on any value between one number and another number. So what we see here, maybe some measurements of weight. The first individual weighs 140.25 pounds. Then the next individual weighs 152 pounds. And then the third individual weighs 161.7 pounds. So this is an example of continuous data elements that are taking on any value between one number and another number. We also have discrete data elements. So discrete data elements are what you might think of as counting individual units as unique and separate. So as examples, we might have 2,000 servers, or 400 dog collars, or 42 ice cream cones. So these would be examples of discrete data. And now let's take a look at what I've called the data visualization stack. So in many of my conversations in data visualization communities, there were a number of disconnects in people's conception of what is data and what is information. And I found myself oftentimes in a meaningful conversation, sometimes debates, over what the definitions of certain terms were. And so what I decided to do for my classes is to basically give my students a guide on what the definition of these terms are how they all related to each other so that they would have an entire system that was all consistent, coherent, and made sense, regardless of who they're talking to. So let's walk through that. So at its central core, sort of the kernel of everything, is a phenomenon, something that goes on in the world. Lightning strikes, or there is airspeed, or water boils, a compound is formed. So these are different examples of a phenomenon, something that's occurring in nature or in the world. Measurements are our observations of that phenomenon. So we might measure temperature, we might measure speed, we might capture visual evidence, we might snap photos, etc. All of these would be measurements, basically captures of observations. From those measurements, we might place those measurements in a collection, some sort of file that we might deem a data source. Now, the data source could also be a sheet of paper in a journal. It could be a table on a website or a newspaper. So any of these could be a source for the data. Basically, where did this data come from? Definitions of the time, the place, the lab, who captured it. Basically, how did these measurements come into existence? That would define our data source. Then we get to data organization. So in data organization, this is where we might take the measures and we put them in a database table or a data table in a document. So data organization is essentially the structuring of that data for use. From there, we then create information. So we might summarize, manipulate that information. We might get the mean, the median, the largest value, the smallest value, all different types of things we might do with that data to create information. But information is basically designed with an idea toward communication. And then above it, we have the interplay between insights and data visualization. So insights might be unique understandings of what we find as we look into the information, common understandings, if you will. And very intentionally, we've included the circular motion with data visualization because it could be that we find the insights and then create data visualization in a descriptive mode. But equally, we might use data visualization as an analytical technique to find insights. So one does not necessarily come before the other. Insights doesn't necessarily come before visualization, and visualization doesn't necessarily come from before insights. It could be either. And so we've organized the data visualization stack in this way. And hopefully you will find this helpful in your future conversations. Now a comparison. So this is a very, very common question. Okay, so tell me the difference between information and data. And this has been the source of a great number of debates. So I thought I would give you guys a very straightforward example of data versus information. So information is a conceptual understanding. It's communication. It operates at a higher level than data. So if you will recall, we captured data about our boiling water, basically different degrees at different times, basically the temperature, a temperature measurement at different times of day. So that is considered data, just like we discussed. So those measurements are the data. But then from those measurements, we might develop information. For example, a conceptual understanding of what happens to water at different temperatures. Specifically, at 0 degrees and 100 degrees, there's a physical state change of water. Basically, below 0 degrees, it's a solid that we all know as ice. Between 0 degrees and 100 degrees, particularly if we're speaking in Celsius, it's water. And then above 100 degrees, we know that as steam, basically the gas form of water. Now, how about an insight? Okay, that's fine. I appreciate the understanding of data and information. Now, what's an insight? How does that relate? So, insights are new or fundamental understandings about the world. We're applying dynamics to our understanding that we got from information. So the information that we had determined is that physical states of water change at 0 degrees and 100 degrees. Okay. Now our insight might be that we have this new or fundamental understanding about the world that all matter has different states of solid, liquid, and gas. Now, the particular information or underlying data might be different if we're talking about copper or lead or gold or something like that. Our different boiling points and freezing points for each of those materials might be different. However, they all have this fundamental common understanding about the world that there's a solid state, a liquid state, and a gas state. So that might be a good example of insights. Now, conversation about data acquisition. So good data is, of course, the fuel for great data visualization. So before starting any data visualization, we're going to need to gather data. So we have to find valid sources of data and gather it together. And then we're going to have to format it for our particular uses, because the form that we find our data in may not be the format that we wish to use it in. So what are some ways that I can find data sets? So one of the ways is by doing basically data searches using a search engine. So I'll try and find some sources of data just using Google or other type of search engine. So some examples, some ideas that you can utilize, some phrases here. So in parentheses, I have here the category. And what I mean by category is anything you're interested in. Six-toed cats, or minerals of the earth, or European soccer teams, revenue accomplishments from the first quarter. It can be anything. Whatever the category is that you're interested in, that's what I'm speaking to here. So sort of fill in the blank for category and then put data. So your search term might be six-toed cats data. Run that through the search engine and see if you get some data sets or data files listed that come back. Second example that you could use, insert your favorite category and then the words data download. So those are often high probability hit rates on data sets. You could also put in a phrase of data file type like, and then put in each of these different file format types, or one of these file format types, your favorite category, six-toed cats, and then data. So the whole phrase might be data file type like XML, six-toed cats data, or data file type like JSON, six-toed cats data. And that might give you an extensive data set about Ernest Hemingway's personal cats. Last example, whatever category you're interested in, six-toed cats, statistics download. So that can often yield data sets for you as well. And so our objective here is not to convince you that six-toed cats are wonderful pets. I have no idea if they are, but basically just give you some ideas on how you can use a search engine to find data sets for whatever category you're interested in. Some popular locations for data. So different databases that are deep and rich available for you. So Google now owns Freebase, so it has a large collection of various data sets that are available for use. Wikipedia, OECD statistics, or the World Bank. All of these have fairly deep and rich data sets available. You can also utilize the published subject databases from the library. So if we've provided this link to you here, and if you look in the screen here, there's databases arranged by subject. So of course we might have particular interest in the business and management databases, but certainly many of these may be useful given that our focus is in business. So you could certainly be taking a look at the business of chemistry, the business of anthropology, the business of art, the business of economics, the business of education, business of engineering, business of film. You guys get the idea. So lots of databases that are available to you, and I encourage you guys to search and find databases that are in subject matter areas that you're interested in. So some of those published subject databases, how to get there. So on the library's website, on the left of the screen, you'll click on the tab for subject guides. So you see that represented there about halfway through the screen, sort of in orange, the clicked on tag there of subject guides. You might type in the different types of subjects that you're interested in. And what will come up is a whole list, just like you might find in a Google search, a whole bunch of hyperlinks for more information about each resource. And so on this one here, you'll see listed sort of the Wharton Research Data Services. It's a very popular data service here in the School of Management. You can also find data sources out on Tableau Public. So listed out there is a number of sample data sets. You can see basically a title for them as well as a description of the data set. And then off to the right, you can see the saved file. The Kaggle website often provides some nice data sets that may be in an area of interest, as well as DataHub. So at DataHub, you can find more than 11,000 different data sets. So lots and lots of different unique data sets. I also recommend data.gov, particularly in the high-value data set area. So down in this area here, you'll find lots of rich high-value data sets that may be of interest to you. And I can also recommend to you census.gov. The Census Bureau measures all kinds of things in what's called the household survey. So if you can imagine a very extensive survey that's done for a sampling of American households every 10 years, where all kinds of questions are asked about where is their household budget spent, what do they spend it on, how many people in the household are employed, what do they do, all that sort of stuff you'll see captured and consolidated on the census website, as well as the main core of their work, which is capturing the census of basically counts of groups of people in different locations in the United States. And some other governmental databases, data.gov, citydata.com, where you find lots of different data from cities. DataCityofChicago.org has a very extensive data set out there. Both Chicago, San Francisco, Seattle, quite a few other cities publish quite a bit of their data online. Now, gathering data. So we can also find data on web pages, data that may be very interesting to us. And using a technique called web scraping, we can basically compile that data together to essentially extract a large amount of data from web pages that are freely available on the internet. And basically what we're doing when we web scrape is we're transforming unstructured data on the web into structured data. So as a simple example of web scraping, I might go out to a web page that I'm interested in. So this one happens to be an ESPN page that has sports team rankings on it. I might manually copy and then manually paste that data into a spreadsheet. I can save it, and then I'll have a data file. Now that's a very simple, small, straightforward data set that might just be on one page. But I might want to acquire a data set that's much more extensive. Like I might want to see the BCS standings for the last 30 years. Or I might want to see the weather every hour, every day for the last 20 years. So that's a much more considerable amount of data. Now that data may be available on a website. It may be, there's a database in the background, and depending on what you request on a web page, it provides you that unique slice of data. But the fact that it's presented on a web page gives us the opportunity to collect all that data together in an extract. In order to do that, we need to engage a process called dynamic web scraping. So dynamic web scraping, it can use a number of different tools, but predominantly, probably the most popular tool is the Python programming language. And dynamic web scraping will basically involve three major phases. We'll identify the source of the data, then we'll fetch the data using Python, and then we'll store the data. So first we need to identify the source. So as we discussed before, we need to search, find a source for our data. We might look at popular websites for the particular subject matter that we're interested in. If we know the type of data we're hunting, we might use any of those different techniques using a search engine that I'd mentioned previously. But ultimately, we will find a source for this data. We'll identify the source. So as an example here, we've identified the BCS college football rankings. And so we have a link here to the football rankings, and these are rankings of the different teams. When we see the university name listed there, what that means is the football team for that university. Then we have to select the scrape. Okay, so we'll navigate to that page's URL, and we'll determine a fixed point in the data structure. And so what we mean by this is we're trying to figure out sort of where does that table begin. So what's a place in the code that we might be able to find where the data begins to flow. Okay, so in this particular case, we might be looking at the top of the table, perhaps the column headings that are in the red or the gray at the top of this table. We might find one, and then we'll choose View Source in our browser. So when we choose View Source in our browser, it switches over from the visual presentation, the HTML presentation, and it switches over, and we're basically seeing the code behind the scenes for that page that presents that page. So once we're looking at the code, we can then use the Find menu, basically choose Find, to locate identifiers from the page view. And here's where we want to find that fixed point in the data structure. You know, perhaps we found a column heading. We're like, okay, the data begins right at this column heading. So then we'll use the Find menu. We'll put that column heading name in Find, and then we'll select Search, and it will take us, often it will take us right to the code for that web page that begins to produce that data. So we'll review the code near the location of the identifier. We'll get a sense for, okay, what are the variable names and how is that data being presented to the screen? We'll look for arrays where that data is being loaded into the web page. We will then create a web scraping Python code file, basically a program. In your assignment, we will have given you an example, the code, and basically you'll need to turn our screenshots into text-based line-by-line code to perform this work. So we'll create that program, then we'll execute it, and we will fetch the data out of that particular web page using this Python program. And what you see in front of you is an example of a data file that we might find from the results of the Python program. So we might pull out the ranking on the far left-hand side. You see comma, team name, comma, and then maybe one of the metrics that is defined. So we'll review our results, basically bring it to screen, review our results, and then we'll store the data. So if it looks like the data we want, we'll then execute commands and store the data in an Excel file format or any file format that we're comfortable using. And at this point, we probably need to discuss some of the ethics of web scraping. So there are often different opinions about what is appropriate and what's not appropriate. The opinions run the gamut from web scraping is totally unethical no matter what, all the way to web scraping is entirely appropriate. It's all out there, so I can just go grab whatever I want. Now, we want to present to you sort of the appropriate data ownership model to act as a guide, an ethical guide in your web scraping. So basically, data is owned by the web publisher or their source. Okay, so whenever this data is published online, it is in fact for audience consumption. So whenever we see a web page, if it has sports scores on it or the weather, it's intended for us to consume that information. Now, The normal mode of consuming that information is with our eyeballs. We use our eyeballs, we process the information, we use our mind. We think, okay, I have an understanding of what's being represented on that web page. Similarly, if the engagement of the web publisher's web page is appropriate, reading that information with the machine is not any less ethical than reading it with our eyeballs. And particularly in the case where we may have members of our audience that utilize screen readers because they're visually impaired. That's an excellent example of consuming that information in a highly and completely ethical way, but it's maybe not the mode of consumption that is the majority or that some folks utilize to consume that information. So it is absolutely true. The data is owned by the web publisher or whatever source of the data that the web publisher has listed. It's theirs. They own it. It is their property. There's no question about that. But that line between reading web data and machine reading is blurring, and it is sort of machine reading is entering into the acceptable realm of consuming information presented on the web. If it's out there, it is intended for consumption. So, and here's where sort of our own self-regulation is appropriate. The data is for you. So it is out there, it is available, but the web publisher's server time is not. And that's the resource that we need to keep our eye on and be thoughtful and cognizant about. It's one thing to say, okay, I do web scrape, it's a fraction of a second, the data is returned to us, the web publisher would be perfectly happy that is in their fair use. Now, if we send a different request and it chews up 5 hours of the web publisher server time, that's a different question altogether. We have now basically acquired a resource of theirs, which is basically a financial resource for our own use without paying for it. And that's basically unethical. That's something that should not be done. And what you'll find with your more sophisticated data providers and website applications, they already have programs that will limit the amount of data that you can pull over a particular period of time. So we're seeing, one, the broadening of that understanding that however the information or data is read, that most web publishers don't feel the need to discriminate in one way or another on how it's consumed. But they do step forward and assert that their server time is theirs and chewing up a server is not appropriate. The other thing I would want everyone to understand is you should always cite your sources. So if you utilize someone's data, you should absolutely cite it. So if it's ESPN's data, you should cite that this data is the property of ESPN or was scraped at this time, this date from the ESPN website, basically affirming that they are the data owner. And if you do that, the web publisher and data owners are not going to mind the usage of their data at all. In fact, it tends to give them more publicity versus less. But everyone likes their assets to be appreciated and to be appreciated for what they own. So just keep that in mind. In summary, data is not the thing. The phenomenon is the thing. Phenomena is at the center of all this. So whatever unique thing is going on in the world, the phenomena is the thing that we're trying to describe. Data is simply a capture whether we're capturing measurements in tabular form, we're taking snapshots, we take a picture of a lightning strike. The picture is a measurement, but the phenomenon is the lightning strike itself. So just try and keep that in mind. Between, the phenomena is the thing. Data is the measurement, one step removed from it. Insights are about the phenomenon. So these unique understandings we have about the phenomena. Information is the organization, data, measurements that we've collected into meaning. So we may reorganize, summarize, take an average of data, and that becomes information. Insights are understanding that we can apply to several scenarios. So they're unique and broad understandings about this data set or about the world. We can acquire data from formal sources, and we can scrape publicly available data. Thus concludes the lecture on data acquisition.